Right, these questions are becoming a feature at the back of the paper. So I've done a couple where it's been like this, where you've got some coordinates that relate to a straight line graph. You have to find a parallel line. This has got a little bit more because it wants the format of the perpendicular line. It wants the end format to be like this, so I'm going to have to do some rearrangements at the end. But the process of it all is pretty much the same. Okay, so what I've got here is I've got two coordinates, and there's another coordinate that's not on the same line. So these two coordinates are a straight line. So I'm just going to sketch what we've got. So just to give you a sense of what's going on. So I've got a coordinate at 2 minus 4. So let's say roughly there. We've got another coordinate at 3 minus 1, which let's say is roughly there. It doesn't matter. You can just see that these are in a straight line like this. Okay, so that's what we've got. And that is at 2 minus 4, and that's it at 3 minus 1. Another point C is at 6, 2, so let's say 6, 2, which is like here, let's say. So it doesn't fit on it. So that's the picture they're presenting to us. Find the equational line that passes through point C and is perpendicular to AB. Okay, so perpendicular to this means it's going to cut through this line at 90 degrees, but it wants us to go through that x, through that coordinate, like that, and it wants to know the equation of that line, so that's what it's asking. So the only thing we can do at the moment, the only thing that we can sort of use to get something from here is to find the gradient of this, because the gradient of one line has a relationship to the gradient of a perpendicular line. So the gradient of this line, and there's a format you can use. In the other video I've done a format for this where you use some a little formula, but that is the rise over the run, if we go back to the gradient idea. So the little triangle I've got, it goes from 2 to 3, so it's 1 along, that way, and that way. So the run's over 1. And the rise goes from -4 to -1, so that's 3. Okay, so that's what I've got from the little triangle I've made. It's supposed to be the right one there. And then 3 divided by 1 is 3. So the line A to B, which is here, through there, has a gradient of 3. So I know that's y equals 3x, and I don't know the y-intercept. But this gradient I can use to find the perpendicular gradient, so where it crosses at right angles. So this gradient, if I go back to 3 over 1, the perpendicular gradient to that is the reciprocal, which means you flip the fraction. But it's not just the reciprocal, it's almost the negative reciprocal. Okay, if this line's going that way, it's got a positive direction. If it's going that way, it's got a negative direction, a negative gradient. Okay, so if that was positive 3 over 1, this will be negative 1/3. Okay, so the gradient of the new line, think about it format like this, y equals mx plus c. The gradient of the perpendicular line, this one, is -1/3. So reciprocal. So that's that bit. But I don't have the y-intercept, this bit here, which I need. Okay, but it does give me the actual coordinates, 6, 2. So if I know the gradient of this line, I can, and I know that the beginning format, I can substitute these coordinates into this to find this missing y-intercept, this c. So it says 6, 2 for the coordinate. So the y value is 2. So -1/3 times by the x value, which is 6. Add c, the thing that we're trying to find. So that's what we're trying to find. So let's have a look. So 2 equals, right, 1/3 times 6 is 2. So it's 1/3 of 6. So a negative of that is -2. Add c. And then to get rid of -2, I'm going to add 2. So c equals 4. So in the normal format, I'll figure this out now, the y-intercept up here, look, is 4. So the whole format, the normal equation is y equals -1/3 x plus 4. That's the normal equation, the line, in the standard format. But what it wants this format where x and y are on the same side, okay, and c is the subject. Okay, so that's what I'm going to do. So, and it wants these to be integers, so it wants this fraction to disappear as well. So there's lots of information. So what I'm going to do is, because they want to be integers, I'm going to deal with that thing now. So I've got a fraction here which is not an integer, it's not a whole number. So to get rid of that third, I have to multiply by 3. But I've got to multiply everything by 3. Okay, and this is what's going to happen. I'm going to get 3y equals, so a third times 3, that's just going to leave us minus x. But I've got to also do the 4. Okay, and when we're doing typical rearrangement, we've structured it, or we teach it in a way where you don't always have to do this. But because I was dealing with this fraction, I had to sort it out now. And now I can move the x across. So to move the x across, I can add x. So 3y plus x equals 12. And if you look at the format that was after, it was ay plus bx plus or equals c. So it's in the same format as what it's looking for. And they're all integers because c is 12, b is 1, and a is 3. Okay, so give your answer in that form. So that's what I've done. So just writing it down here. So a few things involved in that. There's a hidden rearrangement because they're being panes. There is finding the gradient of a line when you've been given 2 coordinates. So it's setting up this rise over run. There is the other one where you can do y1 minus y2 equals x1 minus x2. That's what I did on a previous video, and you can use that again, but I want to draw the picture this time to give you a sense of it. When you've got the gradient of the first line, if you do the reciprocal of that, the negative reciprocal, you flip the fraction, you get the other gradient, you get the gradient of the perpendicular line, you get this gradient here. And then I knew that would give me this of the equation so far. I didn't know the y-intercept, I didn't know where it cut through here. Okay, there are a few ways to figure that out, but I did it by substitution, where I took the coordinate numbers and substituted those coordinate numbers here to give me the unknown c, the intercept, and then I figured out the intercept was 4, so I knew that was 4. And that's where I got this equation from, just putting it all together. It doesn't want it in that format, it wanted it in this format where a, y and bx equals c has whole numbers, and I had a fraction involved, so I had to eliminate my fraction. To do that I multiplied everything by 3, so that became 3y, that became 12, and this lost its a third part, which was after, and then I moved x across to get that, so it was in the right format. Okay, big question to learn because there's lots involved. The processes are easy, but sticking them all together, just realising you know everything there.